Hey all, just thought I should make a video so that it helps in Viva. So this is about PageRank algorithm and this method one, which is finding the eigenvector. So this is the whole concept. You need to find the eigenvector from your link matrix, and then you need to normalize it. That will be your um, final answer. So first step, so there are four steps. One is to find the transition probabilities, then find link matrix that's ingoing. Then you need to solve for eigenvector and then normalize it. So how do you find transition probabilities? Say you have four pages A, B, C, D. So right now I'm in page A. Now there are three outgoings from here. So A to B, A to C, and A to D. So the probability to go from A to B is 1 by 3 because there are only three outgoings. So I'll just note that down here. Say this like 1 by 3. This is also 1 by 3. And this is also 1 by 3. Now similarly, check for B. Now B there's only one outgoing, so it's 1. Then for C also there is 2, so it will be 1 by 2 and 1 by 2. Similarly for D also there is 2, so 1 by 2 and 1 by 2. So now with that we found the transition probabilities. Now the next step is to find the link matrix. So how do we find that? Now L stands for link, so I'll just use L. So say L A. So this is for for page A. So now we just need to make a linear equation. So LA, so in A, what are the ingoings? From B to A, there is 1. And from C to A, there is 1. So, so there is no self loops. So 0xa plus, now from B there is only 1. So 1xb. And then now from C there is 1 by 2, right? So 1 by plus 1 by 2 xc. Then after that from D there is nothing. So plus 0 xd. Then we can do similarly for LB, LC and LD. So I'll just finish that off quickly. So LB, there are 3 ingoings. So there is 0xb, no self loops. And from A there is only 1, so 1 by 3 xa. Then from xc there is 1 by 2. And from D also 1 by 2. Now similarly for C, number of ingoings are from A and D. So from XA 1 by 3 XA, and then from B there is nothing, so 0xB. Then from C there are no self loops. Then from D there is 1 by 2, so 1 by 2 xd. Then again LD, so links in LD ingoings are only from XA, so 1 by 3 XA, and the remaining are 0. So from this we extract our matrix L, that's your link matrix. So L equals to 0, 1, 1 by 2, 0, 1 by 3, 0, 1 by 2, 1 by 2, 1 by 3, 0, 0, 1 by 2, 1 by 3, 0, 0, 0. Now the next step. Now since you found your link matrix, remember the link matrix should be only ingoing, the one which you found over here, and then when you're finding transition probabilities it should be outgoing. So this is something you have to remember. Now here's a fun fact. Now say your ingoing matrix is L, then L transpose will be your outgoing matrix. So in case you do by mistake over here, you calculate through outgoing matrix, then you can just take the transpose to find the ingoing. But for PageRank, we need to use only ingoing. So after this, our next step is to solve for eigenvector. Now, according to your PageRank algorithm, Lx equal to x. So now how do we find eigenvector? L minus lambda I times x equals to 0. Now this is your vector, right? Eigenvector. And this is your eigenvalue. Now another fun fact. For all PageRank algorithms, lambda equals to 1. Now I can prove this also. Now say this is the link matrix which we found for all problems related to this topic. You'll always get a column stoic equation. That means sum of all values in a column will be 1. Say 1 by 3 plus 1 by 3 plus 1 by 3 is 1. Now here also there is only 1. So 1. Then 1 by 2 plus 1 by 2 again 1. So 1 by 2 plus 1 by 2 again 1. So this is not just a column stoic equation. You can indirectly or directly say that lambda equals to 1. So this is your eigenvalue. Now since we know this, we can now find the eigenvector through the equation L minus lambda I x equal to 0. So now let's just find L minus lambda I. So I have substituted L as this, which is the equation we just found. And then this is, now since lambda equals to 1, so 1 times I is again I only. So L minus I equals to this. So L minus lambda I times x equals to 0. Then now you need to find x. So now I'm not writing this in detail because this we have solved multiple questions before. Because it's just finding the eigenvector. So you should be able to solve it. Now this we can just rewrite it like this. So you just need to find after RREF, this will be your eigenvector. Now after you find your eigenvector, you need to column normalize. Now how do you column normalize? Just take sum of all these values. So 3 plus 2.5 plus 1.5 plus 5, 7.75 and divide it. So you'll get 3 divided by 3 divided by 7.75 will give you 0.3870. Then similarly 2.25 divided by 7.75, 0.2903 and similarly for the rest also. So now since you found this is your PageRank vector. So this will be PageRank of A equals to 0.3870 and PageRank of B equals to 0.2903. Similarly PageRank of C and PageRank of D also. So now this is your final answer. Hope it helps. Thank you.